Episode 4, Keywords, Comments, and Operators. Hey Johnnies, welcome back to Gyanvah's Python series, where we learn, grow, and build together. I'm Vishal, and in this episode, we're going to go deeper into the basic building blocks of Python, which are keywords, comments, and operators. These might sound simple, but trust me, understanding them properly will make your code clean, powerful, and bug-free. Let's get started. So the first topic is keywords. In Python, keywords are special reserved words that already have a meaning for the interpreter. They tell Python what to do. And because of that, we cannot use them as variable names or identifiers. As we learned while talking about variables, reserved words are off limits for naming variables. That's because these words already perform specific functions in the Python language. Now let's take a look at what all keywords Python actually has. So let's open VS Code and create a new file called keywords.py. Inside that file, write this line, help, inside brackets, and then inside quotes, the word keywords. Now, let's run this file. You'll see that Python prints a complete list of keywords right in the terminal. Here you can see names like false, true, none, class, if, else, while, for, continue, break, return, try, except, and many more. Each of these keywords has a very specific role in Python. For example, if, else, and elif are used to make decisions. For and while are used to repeat a block of code. Def, class, and return are used when defining functions and classes. Try and except are used to handle errors in our program. And true, false, and none are used to represent logical and null values. So whenever you see any of these words highlighted in a different color inside your code editor, that's usually because they are keywords. And Python already knows what they mean. Now, let's see what happens if we try to use one of them as a variable name. Let's say we try to assign a value to the keyword if. So we write if equals Vishal. The moment you do that, you'll notice that it gets highlighted in red or underlined. And when you try to run the program, Python shows a syntax error. That's because if is a reserved keyword, and Python doesn't allow us to assign any value to it. So the simple rule to remember here is never use keywords as variable names. If you ever get an error like invalid syntax or unexpected keyword, it usually means you might have accidentally used a keyword where you shouldn't have. The command help open bracket keywords close bracket that we just ran is super useful. It lists out all the reserved keywords available in your current version of Python. This is handy because new Python versions sometimes add or remove keywords, so this command always keeps you up to date. Also remember that keywords are case sensitive. For example, true with a capital T is a valid keyword, but true in lowercase is not. If you try to use lowercase true, Python treats it as a variable, and if it's not defined, you'll get an error saying name true is not defined. So to quickly summarize, keywords are predefined reserved words in Python. They have fixed meanings and are part of the language syntax. You can't use them as variable names. You can view all keywords using the help command with the word keywords in quotes, and they're case sensitive. Once you understand these, it becomes much easier to read and write Python programs confidently because you'll always know what's a reserved word and what's a user-defined name. That's all about keywords in Python. Next, we'll move on to comments in Python, where we'll see how comments help us describe our code and make it more readable. All right, let's move forward with our next topic, which is comments in Python. Comments are basically notes that we add inside our code to explain what the code is doing. They don't affect the actual output at all. Python completely ignores them when the program runs. They are extremely important because when you write a project today and open that same code after a few weeks or months, you might forget why you wrote a particular line. So comments help you or any other developer reading your code understand the purpose behind each part. That's why adding comments is considered a very good habit. Now, Python gives us two types of comments. First, single-line comments, and second, multi-line comments, also called docstrings. Single-line comments are very easy. You just start the line with the hash symbol. When you write a sentence after the hash, that entire line becomes a comment. For example, inside VS Code, on the top of your program, you might write something like, "This line prints a welcome message." And then below it, you write your print statement. When you run the program, Python will only execute the print statement. It will ignore the comment completely. Next, we have multi-line comments. These are useful when you want to write longer explanations, maybe 2 lines or 5 lines, or when you are describing what a function or a module does. To write a multi-line comment, you wrap your text inside triple quotes. Everything inside those triple quotes is considered a comment or documentation. Developers often use multi-line comments to explain bigger concepts, like how a function works internally, or what a particular block of code is supposed to achieve. But here's one important thing to remember. Good programmers don't just comment what the code is doing. They comment why it is doing something. Because if your code is clean, the what part is easy to understand. The why is what future you will really want to remember. So yeah, comments may look simple, but they are one of the most powerful things that keep your code readable, clean, and easy to maintain. All right, that wraps up our topic on comments in Python. In the next part, we'll move on to operators in Python, where we'll understand how Python performs mathematical operations, comparisons, and logical decisions. All right, now let's move forward to the next very important topic in Python, operators. Operators are simply tools that allow Python to perform actions like calculations, comparisons, decisions, and many more things. To put it simply, whenever Python needs to do something, we use operators. Python has several types of operators. Let me list them first. First, arithmetic operators. Second, comparison operators. Third, logical operators. Fourth, assignment operators. Fifth, bitwise operators. Sixth, membership operators. And finally, seventh, identity operators. We'll go through each of them one by one with proper explanation and practical demonstrations. Number 1, arithmetic operators. So first, let's understand arithmetic operators. As the name itself suggests, these operators are used for mathematical operations. Before we explain them, let's open VS Code, create a new file, and name it something like operators.py. Inside this file, let's take 2 variables so we can compare everything clearly. Let's say a equals 10 and b equals 20. All right, now let's explore all arithmetic operators one by one. Addition, plus. Addition simply adds 2 values. So if we write print a plus b, Python adds 10 and 20, you'll see the result as 30. Now, subtraction nanus. Subtraction uses the minus sign. If we write print a minus b, Python subtracts b from a, so we get negative 10. Multiplication. Multiplication uses the star symbol. If we write print a star b, Python multiplies both numbers and gives 200. Division, exact division. Division uses a single forward slash. When we write print a slash b, Python gives the exact decimal value. For example, 10 divided by 20 becomes 0.5. Floor division, Floor division uses 2 slashes. This removes the decimal part and only gives the integer part of the result. So print a double slash b gives 0. Modulus percent remainder. The modulus operator returns the remainder of the division. So print a percent b returns 10 because 10 divided by 20 leaves a remainder of 10. Exponent power. The exponent operator uses 2 stars. So print a star star b means a raised to the power of b. That's quite large, but the operator works exactly like that. Now, an important point about arithmetic operators is operator precedence. Just like mathematics, exponents come first, then multiplication, division, and modulus, then addition and subtraction. And whenever you are confused, use parentheses to control the order of execution. All right, that completes arithmetic operators. Now let's move on. Number 2, comparison operators. Now we will understand comparison operators. These operators are used to compare 2 values, and they always return either true or false. Let's again look at this practically in VS Code. We already have a equals 10 and b equals 20. Let's test them. If we check a double equal b, Python checks whether a and b are equal. They're not, so it gives false. If we check not equal b, Python returns true. Similarly, a greater than b, false. A less than b, true. Then you have greater than or equal to and less than or equal to. These operators are mainly used during decision making, especially inside if-else conditions, which we'll be learning very soon. 3, logical operators. All right, now we will move to the next category. Logical operators. Logical operators allow us to combine multiple conditions together, almost like asking 2 or more questions. and then checking if both are true, or at least one is true, or reversing the whole meaning. The three logical operators in Python are and, or, and not. Let's test these slowly in VS Code. So I'm opening VS Code, and inside the file, I'll write two variables. For example, A is 15 and B is 25. Now let's check a simple condition. If I write A is less than 20 and B is greater than 10, both statements are true, so the final result becomes true. Next, if I use or, even if one condition is true, the final answer becomes true. For example, A is less than 10 or B is greater than 10. The first one is false, the second one is true, so the final answer still becomes true. Now the most interesting one, not. If A is less than 20 is true, then not will reverse it and give false. Logical operators are extremely important because you'll use them everywhere in conditions, loops, validations, and decision making. 4. Assignment operators now, slowly moving ahead. Let's understand assignment operators. The basic assignment operator is the equal sign, but Python gives us shortcut assignment operators to make our code cleaner and faster. These include plus equal, minus equal, star equal, slash equal, percent equal, and many more. Let's see how it works. Suppose I write A equals 10. If I write A plus equal 5, it means add 5 to A and update the value of A. Now A becomes 15. Instead of writing A equals A plus 5, we simply write A plus equal 5. Similarly, we have a minus equal 3, a star equal 2, a slash equal 4, and so on. Assignment operators are used everywhere, especially in loops, counters, and calculations. 5. Bitwise operators. Now moving on, let's talk about bitwise operators. These operators work on numbers at the binary level, which means bit by bit. The bitwise operators are bitwise AND, bitwise OR, bitwise XOR, left shift, and right shift. As a beginner, you may not use bitwise operators daily, but these are important for encryption, compression, optimization, and low-level programming. Just understand that they allow Python to work directly on the bits inside numbers. 6. Membership operators. All right, now let's understand membership operators. These are in and not in. They are used to check whether something exists inside a sequence. For example, if you have a list like 10, 20, 30, 40, and you check 20 in that list, that will return true. If you check 50 not in that list, that will return true. Membership operators are used all the time, especially when working with strings, lists, loops, and searching inside data. 7. Identity operators. Finally, let's learn about identity operators. These are is and is not. These operators don't compare values, they compare memory identity. For example, if you create two separate lists with the same values, visually they look the same, but they are stored in two different memory locations. So if you check x equals y, the result may be true because the values are the same, but if you check x is y, the result will be false because they are two different objects in memory. Identity operators are useful for comparing objects, references, and advanced programming. Conclusion. So these were all the remaining Python operators explained slowly, clearly, with examples, and with simple VS Code demonstrations. Operators are the backbone of programming logic, and as we move ahead into conditions, loops, and functions, you'll use these operators everywhere.